So these symbols mean partially positive and partially negative.
Oh.
What that means is, so for this, oxygen is partially negative because in this atom, its electronegativity is much higher than hydrogen's, so it hogs most of the electrons, which causes it to be almost a negative ion. With hydrogen, it's donating its electrons for most of the time, or it's sharing its electrons for most of the time, so it causes it to almost be a positive ion.
Is water polar or non-polar?
Water is polar. It's polar because the two dipoles shown here are going that way, and there's no other dipole coming to cancel them out. So if the dipoles don't cancel out, they're polar.
So now we got to figure out whether oil is polar or non-polar. To do that, we have to consider the concept that polar molecules will dissolve in polar molecules and non-polar molecules will dissolve in non-polar molecules. So let's say we put some oil in a glass of water. Instead of dissolving into the water, the oil is going to form bubbles all throughout the water. So it's not dissolving, so you know that it's going to be non-polar.
Go ahead, Eddy.
See those bubbles? Look at that.
There you go. Right
That's oil.
There's your oil for you, kids.
It's not mixing with the water.
It's its own thing. Water is polar, while oil isn't.
It's non-polar. Okay, so we're gonna figure out what type of force holds water together. So, as we mentioned earlier, hydrogen is going to be partially positive and oxygen is going to be partially negative because of the way the electronegativity is in oxygen. So, this causes each molecule to be polar. And with polar molecules, there are two types of forces that can hold them together. There's either dipole-dipole or there's hydrogen bonding. Now, in order to do hydrogen bonding, you need to have a hydrogen atom and an oxygen atom. And as you can see here, there's a hydrogen and an oxygen. So there's going to be a force that forms right between here that holds those two molecules together. And this happens because hydrogen is almost a positive ion and oxygen is almost a negative ion. So positive and negative attract, so they're going to form a force, an attraction force.
These are two oil molecules. In an instant, their two valence electrons could be right next to each other or anywhere. In this instant, we'll put them right next to each other. And by doing that, they'll push away from each other and to the other side. They'll form a small partial bond, which will make one partially positive and the other partially negative. Because opposites attract, they form a stronger bond. This is what holds oil together. So right here we're going to test their intermolecular bonds. We have water and oil. Water is stronger because it has a hydrogen bond, while oil has a dispersion bond. So let's add water. 1 drop, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Wow. Up. 23.
23 is the number.
Time for oil. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
H2O has 12.
So 15.
15.
So as you saw, water was able to hold 23 drops on top of a penny while oil was only able to hold 15. And this is because in a hydrogen bond, the bond is closer together, it's a very strong bond. So it's able to hold much more of the molecules on this confined space because it's holding it together. While in oil, these bonds only form in one instant, so it allows its molecules to flow more freely around.